Hi everyone. Today we are going to work on restricted range of inverse parent functions. We have some trig functions and we're interested to graph the inverse of them. For example, here we have y equal to sine of x. We know that in order to find the inverse graph, all we need to do is to switch x and y. So if I switch x and y, everything that I had on the x-axis now is going to be on the y-axis, and anything that I had on y now is going to be on the x-axis. So here on the x-axis we had the angles like 0, pi over 2, pi, and so on. They all are going to be on the y-axis now, 0, pi over 2, pi, and so on. And here we had on the y-axis we had sine of angles. Now they're going to be here on the x-axis. Okay, so this is the graph of sine -1. This is what we have. Domain of sine, we know that it's from -infinity to infinity. Why? Because we know that this graph is going to continue itself from the left side and the right side. So it's going to cover all real numbers. Now that I switch x and y, this domain is going to be range of this function. You see that this function is going to continue itself from top and the bottom side. So that's why the range is -infinity to infinity. But the problem is that this graph is not a function, because if I use the vertical line test, I move the vertical line on my graph, I see that at each time it's going to cross the graph at several points, more than one point. This means this graph is not a function. So how do I solve this problem? How do I make this graph a function? How about restricting the range? So for short, I'm just going to write, instead of restricted range, I'm going to write RR. How about restricting the range? Like instead of taking all these values, I take only one part of this graph. Like for example, in this case, from -pi/2 to pi/2. Then I just take this red section of my graph. Now if I use the vertical line test, it's going to cross my graph at one point each time. So restrict the range. Now my new range is going to be all the y values which are between -pi/2 to pi/2, and I put equal sign because the points like -pi/2 and pi/2 are included into my graph. So this is my new restricted range, and in this way I've solved the problem. Now my inverse graph is truly a function. Okay, let's look at the cosine. This is graph of cosine. When I switch x and y, this is what I'm going to see. Again, this is not a function. How do I solve it? By restricting the range, taking only one section of the graph, like this part. So if the range, or restricted range basically, is between 0 and pi, then the inverse is a function. And I put equal sign because they are included. Notice the difference between sine -1 and cosine -1. At first sight, they look like each other, but they have almost the same difference that sine and cosine have. Sine is crossing 0 and 0, but cosine is crossing 0 and 1. The same is happening here. Sine -1 is crossing 0 and 0, but cosine -1 is crossing 1 and 0. So this is the difference between these two. That's how you can tell which one is sine and which one is cosine. Okay, now let's go to tangent. Graph of tangent. And when I switch x and y, this is tangent -1. Again, this graph is not a function. How do I make it a function? By restricting the range. The restricted range is all the y values which are between negative pi over 2 to pi over 2. Do I put equal sign this time? No, because at negative pi over 2 and pi over 2, I have a horizontal asymptote. They were a vertical asymptote for tangent. Now they are horizontal asymptote. And we know that asymptotes are the points that our function is not defined at those points. So they're not defined, they're not part of the section, they're not included. So that's why we don't put equal sign. Notice here, tangent is increasing, and the graph of tangent -1 is also increasing. So from left to the right, it's going up. Now let's go to next one, cotangent. This is graph of cotangent, and the inverse looks like this. Again, I restrict the range because this is not a function. So I take only the y values which are between 0 and pi. Are 0 and pi included? No, because we have asymptote here and here. So restricted range for cotangent is this. And once again, I want you to pay attention that graph of cotangent is decreasing, is going down. And graph of arc cotangent is also decreasing, it's going down. So that's how you can say the difference between tangent -1 and cotangent -1. Tangent is decreasing, tangent -1 is also decreasing. Oh, I'm sorry, let's do it again. Tangent is increasing, so tangent -1 is also increasing. Cotangent is decreasing, cotangent -1 is also decreasing. Okay, now let's go to next one. This is graph of y equal to cosecant of x. And we have learned before, it looks like upside and downside vowels. And how do I know this is graph of cosecant? We know that if we just connect these lines, I see that a sine function is hidden here. This is graph of sine function. So I know this is 1 over sine. Okay. Anyway, when I switch x and y, I'm going to see graph of arc cosecant or cosecant -1. Again, we have the same problem. This is not a function. So I restrict the range. I'm going to restrict the range. How? I take only the values which are between negative pi over 2 and pi over 2. Do I need to put equal sign? Yes, because the point negative pi over 2 and pi over 2, they are included into our graph. But here's the problem. At y equal to 0, we have an asymptote like what we had here. It was a vertical asymptote here, and now it's a horizontal asymptote. So we need to exclude this one. So I'm going to add another condition. Say the y should not be equal to 0. So all the y values which are between negative pi over 2 and pi over 2, but they're not equal to 0. That's my new restricted range. Now, what is graph of secant? Here I have graph of secant, and again, I know this is secant because if I connect these lines, I see the graph of cosine hidden here. So I know this is secant, which is reciprocal of cosine. Okay, switch x and y, and this is the graph. Now, in order to make this a function, I restrict the range in this way. Say all the y values which are between 0 and pi. 0 and pi. The 0 and pi are included, so I put equal sign, but I need to add another condition here. The y should not be equal to pi over 2 because we have an asymptote here. Y should not be equal to pi over 2. So this was today's lesson about restricting the range in order to make the inverse graph, basically a function. Here we have a list of all these restricted ranges. You don't have to memorize them. You can use that whenever you're taking a test or solving a problem. So you can use this as a reference. Have a great day.